Yeah, hello guys. Yeah, welcome back to my channel. This chemistry call. It's been a while that I've dropped videos on my YouTube channel. I want to appreciate the effort of our subscribers for the love they show in subscribing. In few days, we will reach 500 subscribers, and our target is more than 500 subscribers. So today we'll be talking about Aldol condensation. As a chemist, what are the things you ought to know about this Aldol condensation? The first thing I would love to show you guys about this Aldol condensation is one thing that's very good that you should know. The first thing is alkane. Let's consider this. We consider our alkanal, which is we all know as aldehyde, and also our alkanone, which is called ketone now. So if we are to look at the definition of Aldol condensation, we can say in the presence of dilute alkali, alkanal, possessing alpha hydrogen. You know, in chemistry we have the beta and the alpha hydrogen, and where you can locate your alpha hydrogen, mostly if you have a functional group, it reacts to form dimers, or we call it dimers, which is known as aldol. One thing you should know that it is not called aldol just because they are aldol, rather because we can have two possible products. So you can say the name aldol is derived from the fact that the product is both alcohol and aldehyde. So now, if you are to explain this now, for every Aldol condensation, I will advise you as my subscribers that you ought to have a knowledge of what we call alkane, aldehyde, and ketone. We call it alkanal and alkanone. So the first mechanism we are going to take is the first step. What are the first things you should know about this? That is those things you ought to know about this Aldol condensation. So now let's make it brief. The first one is you have to remove the alpha hydrogen from the base. That's the first step now. So if I take a look at this now, I can say I have step one. So I have H. Are you with me? I so I have this and this, then this, a double bond. So now this here is a functional group of the aldehyde plus this. So we're going to have what we call sodium is here attached to this OH now. So this electron here are the outer electron of the oxygen atom now. So if they are coming to this place, we are going to have a formation of a carbanion. So with that now I can say that I have this. So this is the formation of the carbanion. Then we have this C8 double bond O. That is, if I'm to remove the hydrogen here from this carbon atoms here, reacting with this OH now, I'm going to have what we call what plus water. So the next thing now, which is the second step, it is called nucleophilic addition reaction. So step two, the first one is removal of alpha hydrogen, while the second one is nucleophilic addition reaction. So now, if I have to pick this now, I will continue. So it automatically the value I have here, let's say the net product I have for the first step will be the precursor for the second step. So with that, I can say that I have this. Double bond here. Plus, so mind you, this is what we use for the product or the first step. So you're going to write this back here. So with that, like I said, I have CH2, the outer electron of the carbon atoms, CH, the double bond. So what you're going to do when it comes to the nucleophilic attack is that this one here can be the nucleophile, while this would be the electrophile. So when you come together, they are going to form a particular product. So now let's check. I have this. So I have this. Then this my double bond here will change to what? Single bond, because we are going to combine the electrophile and the nucleophile together. But for the electrophile, the double bond will not change. Are you with me now? So let's go to the next step, step 3. So that talks about the protonation of alcohol oxide ion. So when we look at the protonation of alcohol oxide ion, it shows and tells us that for every Aldol condensation where we have a diluted alkali, the dimers, when they protonate with an alcohol oxide ion now, so with that, the product I have here will be the precursor for this. So I have this. Don't forget the outer electron here will now be what? 6. So that will be the carbon ion, which I have a negative sign here. Oh, so we have hydrogen here, CH2, double bond, plus water. So because we want to protonate here now. So from this now, and also this is positive, this one is negative. So when this one here combine with this, I'll be having an alcohol there. Are you with me now? So that will be this, my alcohol, ion is here, CH2, CH double bond, plus OH negative. Are you with me now? So let's take a look at the last step, which talks about the dehydrating of the product to form alpha beta unsaturated aldehyde. I repeat myself, dehydrating of the product to form alpha beta unsaturated aldehyde. So with that now, we have the precursor here gonna be CH3. Are you with me? We have OH, we have H here, CH2, we have this OH. So now when you undergo the dehydrating now, don't forget OH negative now. When dehydrate, I'm going to remove water from the product, from the reactant here now. So we have CH3, C, hydrogen, double bond. And anytime you want to remove water, is that you consider both the reactant side and product side. So here now, I have 2 hydrogen here. This going with this to form what? Water. Because we want to dehydrate. So we have C, we have hydrogen here. Also have what? This double bond now. So guys, I'll show you guys the mechanism of Aldol condensation, how it look like, step-to-step mechanism of it. Don't forget to subscribe, like, unlike, comment. Thanks.